have these charged objects. Well, what happens when we put charged objects near each other? Well, you know that like charges are going to repel, and we know that unlike charges are going to attract. Well, repel and attract are just fancy words for push and pull. Well, if we have a push and a pull, then we have a force. So we have another force. Just like when we made our list back in September, this would be a new force added to it. And this force is only going to work when we have two charged objects. We have to have two. And this guy named Coulomb, that's his last name, is the one that discovered this force, or how to measure this force. So the force is named after him, and it's called Coulomb's law. So all this is a new force. So this is just going to be a force between two charged objects, at least two charged objects. So how do we actually calculate this? Well, we know that the units are going to be in newtons because it's a force. And we know that basically Coulomb's law is just going to be an F. Usually we put a big E after it to represent electric force. But this is really going to be the only force that we're talking about. So you can drop the E if you'd like. But now we need to figure out how do we calculate it. What did Coulomb do? Well, Coulomb figured out that the distance between the charges is what really affected the force, how strong they pushed or pulled each other. So what he said is that this force is going to have something to do with each charge, Q1 and Q2, over their distance between them squared. This should look a little familiar. This should look like the universal law of gravity, but instead of masses, we have charges. Just like the universal law of gravity, we have a fudge factor. We have well, what do we actually need, a constant, to make the data that was found in the field equal the math? So what we have is this K. It's usually a Kc, and it's called Coulomb's constant. So this is going to be our constant. This constant equals 9 times 10 to the 9th. So nice and easy to remember. It's got funny units. Its units are newtons times meters squared over Coulomb squared. Remember, our Q's are our charges. They're measured in C's, they're measured in coulombs. And R is going to be the distance between the two charges. So it's the distance between the two Q's. This has to be measured in meters. So you've got to make sure you're really watching your units. This has to be in coulombs, and remember these are going to be oftentimes in millicoulombs, microcoulombs, nanocoulombs. So get out your cheat sheets for those. And this is going to be in meters. You also have to watch out because a lot of times they'll put these in millimeters, centimeters, nanometers, into tiny numbers. So be ready for small numbers. And then just do the math. This is how we find the force between two charged objects.